Hello, my name is Bob. I'm a math mentor, and I'm trying to teach you children about probability and statistics, specifically 3.1 and 4.1. And today we'll be starting with the probability experiment. An action or trial with specific results are obtained, and the result of single trial is an outcome. And the sample space is a set of all possible outcomes. So an event is a subset of the sample space. Okay, got it. Now, fundamental counting principle. The number of ways that events can occur in sequences is found by the multiplying of the numbers of the ways that events can occur. Got it? Got it? Wow, great. Okay. So the types of probability are classical, where each outcome is a sample space equally likely to occur, and the empirical, or statistical probability, which is based on observations obtained from the probability experiments. The empirical probability is an event E is the relative frequency of the event E. Okay. And the third type of probability is subjective probability. Subjective probability results from intuition, educated guesses, and estimates. For instance, given a patient's health, an extended of inquiries, a doctor may feel that the patient has 90% chance of a full recovery, or a business analyst may predict that the chance of employees can certain companies going on strike is 25%. Do you understand? Wonderful. Now, for complementary events, the sum of the probabilities of all outcomes in a sample space is 1 or 100%. That is the rule. An important result of this fact is that you know that the probability of an event E, you can find the probability of the complement of the event E. Wonderful. And the complement of the event E is the set of all outcomes in a sample space that are not included in the event E. The complement of E is denoted by E and is read as E prime. Do you understand? Wonderful. Okay. On to the next one. My favorite, a tree diagram. Wonderful. Okay. A probability experiment consists of tossing a coin and spinning the spinner shown at the left. The spinner is equally likely to land on each number. Use a tree diagram to find the probability of each event. So, in a tree diagram, you have to look at different events. Events A, tossing a tail and spinning an odd number. And event B, tossing a head or spinning a number greater than 3. The solution from the tree diagram at your left, you can see that there are 16 outcomes. There are 4 outcomes in event A, T1, T3, T5, T7. So P, tossing a tail and a spinner and an odd number, 4 16ths equals 1/4 equals 25.25. Wonderful. Alright, on to a simple event. Sorry, I get a little choked up every once in a while. Okay. Identifying simple events, determine the number of outcomes in each event, then decide whether each event is simple or not. Explain your reasoning. It's very simple, young people. Okay, wait, what is it? Oh. For quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific defective machine part. Oh, that says defective. Oh, okay. Alright, that's fine. So event A. Oh, I messed this up.